Welcome to the Rim Brake Rodeo. We hope this video helps.
You begin by confirming the chair's drive type and battery voltage. This determines motor driver and wiring. Next, mount an Arduino or ESP32 within easy reach of the battery and motors. Once mounted, wire motor driver to the controller and test with simple forward/reverse commands so you validate power and polarity. While doing that, connect a voice interface option, either a dedicated module or pair a smartphone app, so you can proceed to map spoken commands to control signals. Now you build the voice parser and the motion layer. Implement speech recognition on the phone or on device, then map phrases to discrete commands. Once mapped, translate commands into PWM signals to control speed and direction while enforcing current and thermal limits to protect motors. Integrate sensors, ultrasonic for obstacles, bump switches, and an IMU to feed a simple safety loop that overrides voice when a collision or tip risk appears. Then test in short bursts in a controlled area to tune responsiveness. Finish by securing all wiring, mounting enclosures, and adding visible LEDs and an emergency stop that cuts motor power instantly. Next, perform stepwise validation, low-speed maneuvers, obstacle stops, and prolonged runs to confirm thermal behavior. Calibrate voice sensitivity and command confirmation to avoid false positives. If things go wrong, check power rails and grounds first. Many issues are lost or noisy ground connections. Replace connectors. Verify motor driver enable signals, and use logs to isolate whether faults are in voice parsing, control logic, or hardware.
Thanks for watching. Consider subscribing if we helped you.